Hello everyone, welcome to video number 9 of AP Computer Science 8. This video will cover abstract classes and interfaces, and these two topics stem off of inheritance and polymorphism, which you learned in video number 8. So to jog your memory of those two, I'm going to be starting off with two warm-up questions, and I didn't teach you explicitly what you need to know in order to solve these in video number 8. However, given what you've learned in video number 8, you might be able to figure these out by yourself. And if you can't, don't worry. But anyway, here's problem number 1. If you want, pause the video here. The solution will come in 3, 2, 1. Alright, so we have a class called team with the method test. And because of the way that these three classes inherit each other, all three of these classes have the method test. So therefore, you can say any of these three objects and then .test. So that doesn't eliminate any answer choices yet. But then moving on to the parameters. So you can specify a parent class type parameter and then pass a child class object when you're running the method. And the reason for this is because although the child object is not the type specified in the method, it has all of the methods and variables of the parent class. So running the method with the child object will still work. However, you can't have it the other way around. So you can't specify a child class type object and then pass a parent class object when you're running the method. So therefore the answer choice is E, because we have Tom here, and which is a type player, and player is a child of the class position. And then we have Tom here, and so Tom is a player, and this method needs a player. Now moving on to problem number 2. Here it is. Pause if you want. The solution will come in 3, 2, 1. So if you remember in video number 8 about polymorphism, you can have the parent class on the left and then the child class on the right when you're declaring an object. What that will do is it will treat the object as a parent object when it's compiling and a child object when it's running. But you can't have it the other way around. So the answer to this question is D, because it has the parent class on the right and the child class on the left. So now we're done with the warm-up. So now we're diving into abstract classes. So I'm going to create a class called shape. And to make a class abstract, you use the keyword abstract. So abstract class shape. So abstract classes, you cannot create objects of them. However, you can inherit them and create objects of the class that inherits them. So abstract classes can have variables, and just like normal variables, they can be public or private, static or instance. So I'm going to create a private and static variable that keeps track of the number of shapes that have been created. And once you're done putting all of your variables, you can put methods. So abstract classes can have abstract and non-abstract methods. To make a method abstract, you use the keyword abstract. Abstract methods must be public, however, they can be either static or instance. So this method is going to be called area, and it's going to return a double. So abstract methods cannot have a body. So after writing this, you must put a semicolon. You cannot put curly brackets. And I'll explain how to use abstract methods later in this video. So now, as some examples of non-abstract methods, let's create a method that increases shapes created by 1. So this method is going to be called increase shapes created. And the body is just shapes created plus plus. And now let's make the getter for shapes created. All right, so now you can also have constructors in abstract classes. However, since we don't have any instance variables, we don't need those. So now let's create another class. This class is going to be called rectangle, and it's going to inherit shape. All right, so you can also create some new variables that are specific to this class. So a rectangle would have a length and a width, so let's create those. All right, and now let's create the constructor. So we need two ints as parameters. And remember that we also need to increase shapes created by 1. All right, so now notice that rectangle has been highlighted in red, and it says the type rectangle must implement the inherited abstract method shape.area. So this is how you use abstract methods. You don't write a body for them in the abstract class, but you do in the class that inherits them. So now let's write public double area. So the area of a rectangle is just length times width, and we can just keep it as this. Java will automatically turn this from an int to a double. So you might be wondering, what's the point of using abstract methods? Well, if you're going to have a lot of classes and you want a set of methods for each of them, then it's easy to forget a certain method. However, if you have an abstract method, then if you have a class that doesn't have that method, then it wouldn't work. So Java will return an error if you don't have a body for that method in a certain class. So therefore, abstract methods prevent you from forgetting a certain method that you need in a certain amount of classes. So now let's create another class that's going to be called circle, and it's also going to inherit shape. So a circle would have a radius So let's create the constructor. All right, and then now we also need to have the area method. So the area of a circle is just pi, which we'll use 3.144 times the radius squared. All right, so now let's go to the main method. So let's create some objects. So the first object we're going to call x, and it's going to be a rectangle with dimensions 5 and 6. And now let's create another shape that's going to be a circle with the radius of 7. So now let's print out the areas of each of these. All right, and then at the end, let's print out shapes created to verify that it's working properly. So it should print out 2, and I need to put shapes, shape, not shapes created, to make sure it works correctly. All right, so we actually need to use the getter because it's a private variable. All right, so let's run this. All right, so these are all of the correct answers. All right, so now that you've learned about abstract classes, let's jump into interfaces. So to create an interface, first we create a file, and then we write interface, and then the name. So the best way to think about the difference between abstract classes and interfaces is interfaces give you much fewer options. So first of all, variables inside of interfaces must be public, static, and final. Final means that the value of the variable cannot be changed. So a good example of a final variable would be pi, whose value is 3.14. And so after you've declared pi to be 3.14, you can never change it. So if in any section of your code you try to do shape.pi equals 4, that will return an error. So having a final variable is great for things whose values never change, because the first 3 digits of pi will never change. All right, and then methods of interfaces must be abstract, so you don't even need to write the word abstract. So let's create the method area. All right, and then now let's create the classes rectangle and circle. So you must say implements and then the shape of the interface. So when you're using abstract classes, remember that you use the keyword extends, but for interfaces you use implements. All right, so now let's create some variables. All right, and then now the constructor. So I'm gonna create basically the same thing that we created with abstract classes. All right, and then remember that you need to have all the methods, all the abstract methods in the interface. All right, and then now let's create circle. When we're creating the area method, remember last time we had to say return 3.14 times radius, but this time, since we've already declared a final variable inside of shape, we can just say return pi times radius times radius. All right, so now let's create some instances. All right, and then once again, let's run the area methods. And I realize I made a mistake here. This should be shape, not shapes. All right, and it gives the right outputs. Abstract classes and interfaces used to be a topic on the AP Computer Science A exam. However, following the 2019 exam, they were removed. So we will not be doing any practice problems on abstract classes or interfaces. However, I hope this video was still helpful. Even if you think you'll never ever use abstract classes or interfaces, watching this video was still a good review of inheritance and polymorphism. And now we're almost completely done with the topics in AP Computer Science A. In the next video, I will introduce one final short topic, and the rest of the time will be AP exam practice. Thanks for watching. I'll see you in video number 10.